In this video, I'm going to discuss the fifth problem in the assignment 5. So the problem is the task is to design and implement methods of LRU cache. The class has following two methods, get and set. So get the value of what does the get method do is it gets the value of the key x if the key exists in the cache, otherwise it returns -1. And for set method, it inserts the value if key x is not already present. If the cache reaches its capacity, it should then invalidate the least recently used item before inserting the new item, and size of the cache should be initialized in the constructor. So here we are storing the items in cache, so that we should be able to get the data by using the get method and set the data by using the set method. And we need to initialize the size of the cache, so that when we are doing the set and the cache size reaches its capacity, let's say the size is 5, and we already have 5 items in the cache, and for the 6th item we need to remove the least recently used item from the cache. So here for this purpose we need to know what are the least used items and what are the recently used items. So linked list, we can use linked list for this purpose. Let's say the size of the cache is 4, and we are using a linked list here. It's null, and this is head. So let's assume this is the linked list that we have, and if you want to set the item, what you will do is you will just suppose we have only three items. We'll just add the item at the end of the linked list, the 4th item at the end, and let's say we call the get method. So there is a problem in this linked list because we need to start from the head and search for each item, search at each node for the item, and that is one problem. And also instead of that, if we know the address of the node that we want to search, then we could directly go to that node. So let's say we have the address of this node 3, so we could directly go here and just make the previous node, which is 2, it's right to the next node, which is 4, and remove this and add it at the end, so that we know what is recently used item. So recently used item here is 3, and the least used items will be at the beginning of the linked list. And to remove the item, if we have the singly linked list, it will be difficult for us. Again, we need to start from the beginning. So we use the doubly linked list. So if we use doubly linked list, we could just go to the previous node and make its next node to the 4. So we use the doubly linked list here, and to save the addresses of the nodes, we need another data structures. Hence, I am using the map here. So in the map, I will store the all the nodes addresses. In the set method, we'll have x and y, which is a key and a value. So in the map, I will store x as a key, and for the value I'll store the address of the node. So here I'll store the let's say 3, I'll store the address of node 3, so that when I get the get method, then I could use this address and directly go to that node. And also now for the set method, if we already have that key x present in the map, then we could directly go to that node and just change its value instead of adding the new value, new node again. Okay, so let's write the code for this. So to make a node, I need to have a class for it. First, I'll write a class for node. And in the constructor, I will have two values because in the set method I have x and y. So I'm using the two values in the constructor, and I'll store x in key, and I'll store the y in the value. So for a node we have the next and previous because it is a doubly linked list. So this dot next I am setting it to null, and this dot previous is also null. This dot previous equals to null. Now we'll write a class for the LRU cache. Class LRU cache. So we need to initialize the size of the cache in the constructor. So in the constructor, I'll use the size as the parameter. So so we could initialize the size every time we use the LRA cache. We could use our own size. So this dot size equals to size. Here I am using two data structures. One is map and linked list. Other one is doubly linked list. So this one is for map. And for the linked list, I am making a node. For head, new node, and I'm setting the values as nans, not a number. And I am also using the tail, making the tail node and setting its values to not a number. So I am using this dummy nodes because if you want to remove some node, we don't need to check every time if it is a head or tail, because we don't have any previous nodes for the head, or we don't have any next nodes for the tail. It will be null, right? So we don't need to check again if the previous or next is null, if it is head or tail. So I'm just using the head and tail as a dummy nodes, so that we could only use one method while removing a node and replacing it at the last. And then this dot head dot next equals to this dot tail, and this dot tail dot previous is this dot head. Now let's write the get method. So our first method is get. In this, so whenever the get method is called, first we'll check if the key x is present in the map, so that we don't need to search in the linked list for the node. So that we could just return the -1 if it doesn't exist in the map. Sorry, this dot map dot has x. So if we have this key in the map, then we'll just print, so console.log this dot map dot get x. So if we do this dot map dot get x, the value of the x in the map is address of the node. So we get the address of the node. In that node we'll store the x and y as a key and value. So we need to return the value of it. Hence I am writing dot value. Then we need to move that node to the end of the list, so that it becomes the recently used node. So for that one I will write a method called move to last, and I'm gonna write it later. And if the key x is not present in the map, then we could just print x does not exist. So this is the code for the get method, and now we'll write the code for set method. And we have two parameters, x and y, which are the key and value pairs. And now so if we already have the x, we need to update the value of y in that key. So we'll check if this dot map has x, then all we do is we go to the address of that node and update its value to y. Then once we update it, we need to shift it to the end of the linked list, so that because it is the recently used node. So again we are using this dot move to last method, which we will be writing later. Else, let's say if that is not already present, if that key is not already present, then and first before we enter the new item into the linked list, we need to check if the size of the linked list is reached its capacity. So if it's reached its capacity, we need to remove the least recently used item, and then we need to add the new ones. So we need to check if this dot map dot size is equal to this dot size. So we have initialized the size in the constructor, so we'll check if map has reached the size of size equal to this dot size, and if it is equal, then we need to remove the first node from the linked list. For that um, I'm declaring a variable in which I'm storing the head dot next, because the head and tail are dummy nodes. So the next node to the head is the first node. So we need to delete that node from the map also. So I am deleting it from the map, and then so I'm for the head, I'm making the next node to the head as the current dot next, and then so this dot head dot next to the next node, and this dot head dot next dot previous equals to this dot head. So let's say the map size is not yet reached to the size, then, or even if it is reached the size, we just remove the first element. Then now we need to add the new node at the end of the linked list. For this for that we need to create a new node first. So let's say constant new node equals to we already wrote a class for the node here, so we'll just use that to create a new node. So new node of x comma y, and I'm using a temp as a variable, temporary variable, in which I'm storing this dot tail, and in the previous I'm storing this dot tail dot previous. So if we have nodes like this, and we need to add the new node after the tail. So what we will do is, so we do previous dot next. So sorry, we're not adding the node here, we'll be adding it in the middle here, because this is tail, which is a dummy node which contains nan as the values. So we need to add it before the tail. So we need to make this nodes next to this one, and this nodes previous to this, and we need to make the current node to the next to the tail. So for that we are doing previous dot next equals to new node. So this is previous, and we are making it next to the new node, and new node dot previous equals to previous. And now new node dot next should be equals to the tail, so it is equals to the temp, and temp dot previous is equals to the new node. So now we have created the new node here, and so whenever we create a new node, we need to enter it in the map also. So for that we are using this dot map dot set. So x as key, and we need to store the address of the node as the value of the key in the map. So in the key I am using the new node as value in the map. So we are all done with the set method here, and now here we have this move to last method, and now we are going to write that method. So move to last. In this, what we are going to do is we need to remove a particular node and from its address and move it to the end of the linked list. And also we need to update its address in the map. So first, let's say let current equals to we'll store the address in the current address of that node, and we are going to get that from the map. In the pre variable, we are storing current dot previous, which means the previous node of that current node. So let's say we are removing this node, and so this is the current node, this is the current, and this is the previous node, and this previous node's address we are storing it in the prev. And now what we are going to do is we are doing prev dot next equals to current dot next. Since we need to remove this, we are making this nodes next to this one, and this nodes previous to this one. So current dot next dot previous equals to prev. Now we have removed this node, and we need to add it at the end of the just before the dummy tail. So for that, adding at tail. For that, what we need to do is let's say this dot tail dot previous dot next equals to current, which means so this is the tail. So tails dot previous is this one, and for this nodes next we are making the current is this one, so we are removing it from here and making this nodes next to current. So here the current is here now, and then we also need to make it previous to the this one. So current dot previous equals to this dot tail dot previous, and we need to connect it to the tail also. So current dot next is tail, current dot next is this dot tail, and we need to have the previous for the tail. So this dot tail dot previous is current. So now we have added the this node at just before the dummy tail, and now we also need to update its value in the map. So for that we are doing this dot map dot set for the value for the key x. We need to store the address of that node. So this dot tail dot previous. So this is the address of that node, and this is the end of this move to last method. Now let's see the function from the starting. Let's say we got key value pairs as a as key and the value is 1. So first we'll we need to give the size of the constructor, and let's say the size is 4. We'll have a new map. So we'll have a map, and we have two dummy nodes. One is head and one is tail, and those are connected to each other. And then since we have given the a and 1 as value, we need to go to the set method. So I'll write it in here. We have head and tail, two dummy nodes, and a as key and 1 as value is given as input, and now set method is called with these values. So we go to the set method. Since this is the first value, we don't have anything in the map, so we just go to the else, and we check if map.size equals to the size. So we don't have any items in the map, so this becomes false, and we directly come here, and here we are creating a new node. So we create a new node with x and y values. So here in the node the key becomes a and value becomes 1. Now what we are doing is we are adding this node at the just before this tail. So this new node will be added here, and we'll change this next and previous of the head and the current node, and current node's next becomes tail. Then we need to set this value in the map. So in the map, we'll for key we store x, which is a, and for value we are storing the new node's address. So with this new node's address will be stored as the value. So address of a. Now let's say we call the get method. So get method is called, and for in the get we called a. So here we have the get method, and now we'll check in the map if the map contains the x, which is a. So this is the map, and it contains a, and the a what we have is address of address of the node a. So we go to this address, and we are going to print out this dot map dot get x, which is the address of the node A, and dot value. So we go to this node, and what is the value we have here is 1. So if we call the get A, 1 will be printed. And let's say we have 4 nodes. And now we call the set method with values b, and b as key, and y as 2. Let's assume we have set the size of the linked list to 4. Then what we are going to do is let's say this does not we don't have this key b in the map, and it goes to the else condition. And the else condition, we check if map dot size equals to this dot size, and yes, we have 4 nodes in the linked list, and it is equal to the size, which is 4. Then what we are going to do is we need to remove the first node. So we have head as a dummy node here, and the second node is the one that we need to remove. So what we are doing is, in the current we are storing this dot head dot next. So head dot next is this one. We are storing this in the current, and then we also need to remove it from the map, right? So we are doing that this dot map dot delete, and then so we are making the head dot next to the this node, and to the current dot next, which is this one, and this one's previous we are making it to the head. If you see here, head dot next dot previous equals to this dot head, which means the previous of this node becomes head. Hence we are removing the first node, and then what we are going to do is we are gonna add the new node at the end of the at the end of the linked list. So this is code for the LRU cache, and we have written the methods for get, set, and move to the last method. Thank you.